Sure, yeah. Thanks so much for the introduction. Yeah, so I usually go by Herman, and I'm now in Department of Performing Arts Technology, but most of it is music technology, of course. Echo?
Yes, because maybe the volume is too high. Can you talk a little bit?
Hello, hey, 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 hey. That's better? That's better? I think the lower one, right?
This one, no?
Is that working?
Yeah, I think it's okay.
Okay. Or maybe I should just move it away.
Yeah, maybe so.
Cool. Nice. So yeah, as Xavier mentioned, I'm in the School of Music, Theater, and Dance, but so I'm currently expanding my research to touch on different aspects of music. Cool. So today, rather than digging into a lot of my research, I will sort of like give you an overview of what I work on, and I think most importantly, I want to talk about some of the challenges and opportunities in generative AI for music and audio. That's generally my research in the past few years, but now I'm also expanding it a bit. Cool. So just to get started, let me see. Cool. So this is one of my research philosophy that over the time we see this music and technology co-evolves. So in the past, in the classical music era, you see that violin making, this engineering actually co-evolved that technology then co-evolved with the classical music, and you design the concert hall, you design the acoustic, and also nowadays you see all these invention of synthesizers, also all these digital audio workstation, those that create some of the new music genres, say new age and all the electronic music nowadays. So often the time you see, and nowadays we have this AI wave that's changing the way how we interact with music, but also unlock so many different opportunities of music. And so here I'm just showing some of the examples that AI has actually been used for music on stage. So you see this is one of the collaboration with Yamaha and the dancer in Japan. They are using, there's like this spot that I couldn't enter. So you can see all these, EMG that connected to the muscles. And so you can use those muscles as signals to control the piano at the back. There's also Shimon at Georgia Tech. They have this like robot-like, as we will see later, the robot-like interaction with musicians. And so this allow a more digging into what this AI and robotic means for music. And this also Yamaha's Symphony, they work with a pianist who has cerebral palsy, but they enable her to actually play with only a single finger, but they will accompany the full composition for the piano so that she can actually play on stage. And this is more like, nowadays a lot of AI is being explored on stage. It's like creating live images. That's not Gen AI for music, but that's also an opportunity for stage performance. But also, Gen AI for music and audio, I think a lot of time people forgot how expensive it is. So you can think about film, think about theater, think about gaming, think about dance, think about podcasts, and also nowadays a lot of show videos. Gen AI for music and audio, but also more broadly content creation has been used in so many different ways. But recently I'm also very interested in looking into opportunity for music education, but also music therapy. And also lately I'm also thinking about injury prevention and hearing loss prevention. How can we better use AI into these more impactful fields? But in general, just a sort of overview of the way how I view music and technology interact. So on one hand, art challenges technology, but on the other hand, technology inspires the art. And so this is a very nice quote that I like. And so my research is about how can we augment human creativity with AI. Today I will mostly talk about music and audio, but I also work on some application in video editing, but also think about sound design and film scoring, because I'm a big fan of movies and music. So film music is sort of at this intersection of that. Cool. So just a slide of some of my past research in AI for music. I've worked on multi-track music generation. I will talk a little bit about it later, and also expressive violin performance synthesis, text to music generation. These are mostly in symbolic domain, but also video to music generation. And recently I've been expanding a bit. So I also work on music arrangement or LLMs for music, but also choral music separation. That's sort of a new direction that I'm leading nowadays. Optical music recognition. I recently also got a grant to work on optical music recognition for MMIR for guqin, a traditional music instrument. So sort of work on a lot of different things, but still mainly on Gen AI for music and audio. So for the next few slides, I want to talk a little bit about some of my past research. It will be just one slide each, so definitely not into details, but feel free to stop me if you have any questions. And then after that, I will talk about some of my views on the challenges and opportunities for Gen AI for music. Cool. So this is like when I get started. It's actually in 2018. So this is, at that time, I think I'm naive enough to think about, we have seen a lot of, music, symbolic music generation for generating music. But people have mostly been thinking about melody plus chords. So, think about lead sheets. But at that time, people hasn't really dig into, how we can generate multi-track music. Of course, there are, lead sheet generation that's still somehow like multi-track. But here we are thinking about, well, now we have all these very powerful music generation systems, generative models proposed in machine learning side. Can we actually generate different multi-track music, and all of them are polyphonic? And so we look at the then, GNNs, the then, state-of-the-art machine learning models. And so we are looking into how we can generate multi-instrument music back then using GNNs. And so here we are using, likely most of you might know, so multi-track piano roll, but basically, piano roll, but we just stack them into like a huge image kind of thing, or think about multi-channel. So we use GNNs to generate these multi-channel piano roll. And as you can see, visually, that you can definitely see a lot of things that sort of naturally match the CNN idea, right? There are filters for the drums that repeat, and also for guitar, those chords that can be repetitive, and that's also translational invariant. So that natural fit the idea of convolutional neural network. And so we basically propose this now looking at it, too complicated model, but basically the idea is to see can we generate multi-instrument music using GNNs. And so here we are only generating only 4 bars of music, and that's one of the big constraints of GNN-based model, that you can always generate, you can only generate fixed length music. So unlike nowadays, we are thinking about transformer, thinking about these autoregressive models that would just generate on the fly, even though at some point it might blow up. But I mean, here we are talking about generating like a fixed set of music. So this is the music that we can generate it back then. So this 8 years ago. Cool. So, you get a sense that, this is like 8 years ago when we are started to look into, how we can generate multi-track music using GNNs. And of course, nowadays, now we have like different transformer and all these different symbolic music generation system. But one of the things that's kind of cool is that Musica is actually featured in this AWS Deep Composer, which is unfortunately very bad review and now discontinued, but still cool to see that, it's actually featuring one of their models. There's just like 2 models, which is kind of cool. And I didn't get a chance to play with it. I should order one, but back then I was a PhD student and poor, but now I regret. Anyway, so fast forward to 2023. Now we have all these music transformers, but still people haven't done enough to look at multi-track music, because multi-track music is much more complicated than piano, right? Piano is single track, so you can basically assume the sequentialization. But how do you do multi-track? So in this work, basically we think about how can we better represent multi-track music. And so a lot of time, as you might know, for symbolic music generation, we talk about representation again and again. Because once you have the representation, a lot of things is just like the GAN, transformer, or whatever model you apply to that representation. And a lot of features of your model actually just come from the representation itself. So this is the representation we use. At the left, this is the model C, and at the right is what it means. So you can see that we have at the first column is the type. So 0 means like the type of, so 0 is always soft songs, and 1 is instrument. So you have different instrument. Instrument is determined by this column. And then you have a bunch of notes, that's 3. And then you have encoded all the information, beat, position, pitch, and duration, and what instrument to use. And of course, at the end, you have EOS, just like typical transformer. So once you have this representation, now you basically train the model to do it. But one of the benefits of that is that it can actually do a lot of things with this representation. And so the model that we use is just a multi-track music transformer, but think about it, it's just a transformer. Other than generating one single number, now we generate 6 numbers at a time. And these 6 numbers all together determine a note. And so that's different from other music transformer model where you talk about, well, beat, duration, pitch, instrument all at once, and then you combine them together. Now we are generating note by note, and every time you generate the note itself. And so this get into a very efficient, compact representation for the music. And there's another benefits of doing this representation is that you can actually do instrument condition generation. So think about nowadays we are doing prompt engineering for LMs, right? So one thing you can do is that you can actually go from the start of song all the way to stop notes, and then you stop here, and then ask the model to generate the rest. So you can actually sort of like determine the recipe, and then ask the model to generate. So a lot of things, again, in symbolic music generation, we are thinking about how can we create such representation to enable different kinds of features or characteristic of the model. And the model doesn't have anything fancy. It's just a normal transformer, just that it outputs 6 numbers at a time, and it takes 6 numbers at a time as input. Any questions so far? Oh, good. So one thing that's in addition to just presenting this model is that we also look into musical self-attention. This is kind of interesting because a lot of time people are have you seen the music transformer, like the attention mechanism thing? Like you can actually visualize some of those attention, but a lot of time we don't really have like a statistical understanding of how these musical attention work. And so in this work, we also present a statistical understanding into whether musical-wise, the model is actually doing something reasonable. So these are 2 of the things. So this is one of the things, it's very fainted. But as you can see, these models are attending more to things that are 4/n beats in the past. So that's because our data is mostly 4/4. There are some 3/4, but you can see these stars lines, you can see stripes, very fainted here. But on the paper, you can see those. And this is another thing, this is the position, this is the pitch. The pitch is also interesting because you see that it actually attends more to 4ths and 5ths for those harmonies, pitches. Questions so far? So this is different from just looking at the transformer and then look at the visualization. Looking at the visualization, oftentimes you're like, the model is making something, right? And you explain on the way, but you don't really have a statistical understanding whether they are actually doing something. And of course, these is a very surface level understanding. The model attend to 4/n beats away in the past. The model look at notes, they are harmonious, but it doesn't tell us a lot. But at least these are some verification of whether the model is working in the way as we intended. Cool. So this is another project. This might be more fun. So this is even before the project that I just talked about. So here we are thinking about automatic instrumentation, or more fancily, you can call it orchestration, even though we don't do a lot of orchestra in this case. But the core idea is that, well, oftentimes on the keyboard, we have zoning, that on different zone, you can play different instruments. We are thinking about, can we play piano as usual, but somehow it can generate multi-track music at on the fly. So the biggest question here is that we don't really have any data with that, right? For say Liszt has composition or rearrangement of some of the Beethoven's symphony, so you get pair data. But how about contemporary music? So the thing that we think about is that, well, we do have a bunch of multi-track music, so these colors are all the different instruments. And so one thing we did is that we just pretend it's piano, right? We just make it into black and white, and we assume it's just piano. So now we want to train this model. We call it part separation model. We want to predict all the labels, all the instruments for each of these single notes. So once we've done that, then we can actually do something like this. It sounds crazy, but I mean, you can do it. So you have this play by guitar, not piano. But now you can ask the model to colorize it. So this is like a very simple machine learning algorithm, right? You just look at each single note, and then you want to predict what that is. So it's sort of like name entity recognition or whatever you call it. But basically, you want to attach a label, an instrument on each of the notes. But now you can do something like this. And so, this is you can do it offline, then you can use as composition tools for, genres that you are not familiar with, or ensemble you are not familiar with, but also, think about, we also have an online version. Still haven't. I was thinking about it for a long, long time to actually create a keyboard that you can play with, and then you can do online labeling on the fly, but still haven't been able to do that. But we actually have a model that uses online, LSTM-like model that can actually, doesn't require the full context. You don't need to look into the future. You only rely on the past information to make you a prediction. So those can be used in real-time applications. Cool. So any questions so far? Oh, good? Cool, I would just keep moving on some of my past research. This is another research I've done, synthesizing expressive violin performance. So oftentimes people are breaking these different steps into different research, and here we are thinking about, can we actually do not end-to-end, but at least from one side all the way to the other side within the same framework. So all the way we want to go from row score, and then we want to create expressive timing for the duration, for the timing and duration, and then we want to turn it into mail spectrogram, and mail spectrogram, we will turn that back to waveform. So basically, we adapt something from text-to-speech synthesis. So if you think about text-to-speech, and then think about score to audio, and then realize how similar they are, right? Text-to-speech is that you have single words, and you don't know how long those words will be, how loud, and how do you adjust the prosody of that. But I mean, for a score to music, it's similar, right? You have dynamics, you have timings, and you have to figure that out. So we basically adapt the similar pipeline in TTS, text-to-speech, and then we adapt it to score to audio synthesis. And this is what we can get. As you can see, let's just listen to it. This is that violin synthesis. Cool. So one of the big things that we did is that, as you can see, even for violin, there's tons of polyphonic. And this is the piano case. So one of the big things that we need to do, unlike TTS, people likely won't be able to talk two sentences at the same time. But basically, we can adapt some of the idea in this TDS model so that we can, so this is the polyphonic mixer. So now instead of being one word by another word, and then you just expand them into different lengths, now you have to remix them. So here you have two notes that's happening at the same time. So you want to add them together. So this is sort of the main technical innovation in this work. But the core idea is similar, is that text-to-speech with some polyphonic mixer kind of idea, then we can adapt it into very low resource violin synthesis. In this case, we only use 6 hours of Bach public domain and CC license recordings of Bach's sonatas and partitas. So it's very, very low resource. So consider TDS, usually they use 24 hours is the minimum. And of course, commercial ones, they use much more than thousands of hours. But in this case, 6 hours, that's what we can get. Questions? Okay. Cool. This is the last project I want to talk about before I entering into more like a meta sort of analysis and discussion about the challenges and opportunities. So this is like a relative new work that we've been working on, video to music generation, but more precisely, video-guided text-to-music generation, as you will see later. So the first thing we did is that we collect this open-screen soundtrack library. So these are 736 video clips from almost 300 films in public domain and CC license. And you can see the years, then you will get a sense that's, sort of the public domain kind of movies. A lot of them are black and white, but of course over the time there are certain movies that are released on the CC license, but sometimes they forgot. Most of the time they forgot to renew their license. And so it just jumped into public domain. There's also one famous movie, Day One, when they release it, they have the movie and then they forgot to add the copyright. So they enter public domain Day One. So some of these are possible, even though we are now mostly in copyrighted, music or video domain, but there's still some, not a lot, but I mean some data that's available in public domain or CC license. Anyway, with this like very small data set, how can we do video to music generation, right? It's just seemingly impossible, right? Think about all these big models, how do we do it? So we don't do video to music generation directly. We think about how we can adapt or improve a text-to-music generation system. So this is like just a typical music gen. So if you know a little about music gen, what music gen want to do is that you want to generate similar to what we are talking about for symbolic music, for node by node generation. But now music gen is generate some tokens. These tokens represent to certain encoded, sort of think about MP3 bytes. So you are generating a bunch of MP3 bytes on the fly, autoregressively, and these things will be decoded later, but the core idea is that you are generating some compressed version of the music in audio domain. And that is being conditioned on some text. So you have text, you go into this music gen encoder, and so this is like a sort of like a big transformer model. You have this part is talking about how you can generate the music on the fly, but at the same time you want some cross attention, some information flow into this thing so that it will look at the text while it's generated on the fly. And so the text will be a film soundtrack for a happy scene, blah, blah, blah. So anyway, for all these video clips, we do have the text. And our core experiment is to think about, well, if we have the video, can we do better? And so again, this is not doing video to music generation from scratch. We are thinking about, well, if additional visual information can help improve the text-to-music generation. So we call it video-guided text-to-music generation, but still, the idea is that, well, we don't need a lot of data. We basically just adapt existing data. So everything that's in blue is that we don't train it. And so we only train these two things. So these are actually quite small. But still, I mean, we can look at the examples. But again, think about, even if we don't have the video, if we only have the text, it's already doing a great job. But these visual information are providing some of the visual rhythm, some of the coloring, some of the genre information that's unavailable from the text. So this is the example. Is it playing? Yes. Cool. Just to clarify, we didn't generate the sound effects. We separate the sound effects and add it back. So only the music is regenerated. And these are public domain film, and you can see from the colors. But these are our data set. This is another example. This one is interesting because a lot of the data set is just like the opening scene. You don't really get a lot of information there. Cool. Cool, I will skip this. And this is like commercial film. So we adapt our model, train on public domain films and CC license, mostly black and white, to commercial films.
Sheriff Laughlin, Terry Husk. I had a question about some flyers I keep seeing. White power. Is that the Aryan Nation? You know what my problem is with every fanatic?
You have to have somebody to blame for your life.
Those pamphlets you saw? It's not all. This was in June. A bomb went off at a synagogue in Boise. That's just the beginning.
Cool. Last.
Every day something is breaking.
And we're dead. Again.
Yeah, we're blowing up.
The space program.
It's actually a
is
comedy.
evolving
Needs
Yeah,
a marketing
so-
specialist. And
I would say the model doesn't realize that it's comedy, right? So the style doesn't really match. But I think that's also the very interesting thing about film scoring. And I'm very interested in that because I think the creative space is very big, right? Because a lot of things you still have to match the general coloring, the genre, the visual rhythm. There's something you can align, but at the same time, there's a lot of creative space, and that's why I think that's very, very interesting. Any question on this? Yeah, okay, a bunch, cool, yeah.
Do you ever change the text prompt during generation? It's just one text prompt?
Just one text prompt. So we have the text prompt for all the music. We have someone to annotate it, caption, yeah. And so the main experiment is on with text only, and then we use Music Gen. And then we compare that with text plus video. And we show that text plus video is better than only text. But at the same time, you know, think about video to music generation. This is not that. It's, you know, more like video guided text to music generation. Yeah, cool. Yeah.
Yeah, I want to ask, how do you evaluate the performance of video clip and text in comparison to just text?
Yeah, there are some automatic metrics, but I think the only thing I trust is human. So at the end, we use subjective test. Yeah, yeah.
A quick question. How close were the generated audio to the original audio that the movie had?
Quite far away. Yeah. So it's never the same. And as you can see, like, you know, when you adapt like public domain video, sound, and even if you listen to the sound quality, it's different, right? Because in the past, like movie, a lot of them are like real orchestra, and there's a lot of a rubato. It's not like nowadays, like sort of like more produced music, and they like those like live orchestra back then. But now we have like different kinds of genres. Yeah, so I would say differ a lot, but I think the core here is to think about what visual information can be provided. And also regarding the evaluation, that's actually also another not ongoing, very slowly progressing research I'm working with my students is to think about how we can actually evaluate that. So think about music and visual. Can we train similar kind of sort of parallel contrastive model that look at music and look at the video? Can you see those visual rhythm and music rhythm actually align? So what we were thinking about is that we can take the music and take the visual. Now we move the music around, or we expand it, compress it. And so the only time that match is the original setup. If you lower it, then the rhythm doesn't match. If you move it around, then some of the cue doesn't align. So that allows us to build some kind of like self-supervised models to actually evaluate that. But again, that's only looking at some of the nuanced temporal alignment. There's a lot more that we cannot evaluate. Yeah. Cool. Yeah.
How do we adapt the data?
The data?
So you said you adapt it to the commercial goods?
We adapt. So okay, I didn't explain it enough. So video coming from this string. So so this is the original music gen. So music generated on the fly like a transformer. Now you have text that's conditioned into it. Now we have video. So video go into this vivid. We don't train it. And so now the only thing is that this things output something. We want to get additional linear transformation. This linear transformation will be added on top of this cross attention. So now this thing is actually 0 initialized. So at the beginning, the video doesn't contribute anything to this thing. So this things will be just like without video. Now the video will add in more information to this cross attention. So hopefully some of this information will be passed into the cross attention.
What do you call this adaptation?
How do we call it? There's no name, it's just video adapter. We typically just call it adapter. So having like an existing model and then we want to integrate into something. So I would say similar to control net in some sense, but people just call it adapter in so many different cases. Yeah. Cool.
What is the average length of the clips?
The clips, I forgot the exact number, but I mean, this will be short because music gen is only 30 seconds or 10 seconds, depends on which music gen you're using. But the original film is much longer, so we just chop it.
Okay,
Yeah.
which leads to the second question. Since the data set is very small,
Yeah.
and most of the model is frozen, which techniques or features make it possible to use such a small data set and get that type of result?
Oh, you mean the feature? So that's the reason why these things are all, fixed, right? Because this VVT is actually a big visual encoder that they use to do all sort of different downstream tests. You can do, like human facial recognition, object segmentation, all kinds of like visual downstream tests. And so we basically just grab it. But this is for video. And so this thing is like huge computer vision models. So these are huge, and it was trained on thousands of hours of videos. And so we don't touch it at all. So this thing just outputs some vectors, right? And those vectors contain important information, because otherwise how do they enable all those downstream tests, right? And so that's the reason why we name it adapter, because these adapters are just looking at extracting. We don't extract new information from this. We don't learn to extract new information from that, but we expect this encode some of the information. And so some of these features are important, some of those are not. So these adapter is just looking at extracting those important features and add it back to the cross attention. And that's how we can enable the training. The data set is actually not that small as you might expect, so 736 video clips, but these video clips can be 10 or 20 minutes. So yeah, it's not like 10-second clips. Yeah, it's longer than that. Usually it's like 3 minutes or 5 minutes. So those are soundtracks. So the way how we create this data set is that we don't use the original YouTube sound, because those are very low quality, audio quality. So we actually go to find the OST, the original soundtrack, and then we get those music, and now we do alignment, and then we grab the video and pair with the soundtrack. So soundtrack is usually 3 to 5 minutes. Yeah, so not big, but actually not as small as people expected. So clips is like 3 to 5 minutes, usually, yeah. Cool, so, yeah, so this is pretty much some of my work on Gen AI music, and of course with different collaboration, and while I'm at different institutions, and also interning at different spaces. Some of those are Adobe, some of them are at different companies. Cool. But yeah, so that's just give you the sense. But today, I think the main things I want to talk about is about the challenges and opportunities of Gen AI for music and audio. So more like a meta-analysis of where we are at and what we are looking at next. Cool. So I will just show it here. Again, like disclaimer, this is just my personal view. I think there's still tons of things. I keep updating the slides, but there are tons of things that I didn't cover here, but these are some of the more immediate and possible, feasible next step that we are looking at. So representation, multimodality, usability, personalization, and creativity. I will dig into each. How am I doing on time? Oh, I'm running out of time, but we'll see. So first, representation. We've seen a little bit on it. So music generation, roughly speaking, 4 paradigms, very naive way or way of categorization, but text-based, MIDI-like, generating sequentially, image-based, more 2-dimension time series for audio domain. Also, you can build it as spectrogram. So I would say this is roughly 4 paradigms of them. This is the thing that I was talking about, visualizing music, self-attention. But you can see some of these case studies. You can see that while generating this note, you look at the current chord, but you also look at the first chord. But at the same time, as I show, I clicked the wrong button, as I show in this case, that we can actually do statistical analysis. But again, right, so we look at these music transformer things, then we sort of like viewed it as a sequentialized generation way. But at the same time, because I also work on piano roll a lot, but if you look at the piano roll, you will see that a lot of things actually are quite obvious when you just visually look at it. And that's also why a lot of time people just look into those, and then you see some of these cool visualization. People also compose visually, just drawing spectrogram or piano roll to create music. But you can see these like translational invariant things on melodies, chords, scales, and arpeggios. So this brings me to sort of the first things that we are still unsure. We also talk about this. So this is Musica. So when we are generating piano roll, so this is the thing that I show. And I just showed the final things. But GN is like while you are training, it started from mostly noise. And then you see that the drum started to have some patterns. And some of these other instruments it will learn over the time. There's also cascaded diffusion models. This is one of the first model that can actually generate full song structure in symbolic music generation. So how they did it is that they go from each step, level 2, level 3, level 4, and adding more details into the model. I won't go into details, but go from reduced melody, so without a lot of tempo, just get the rough melody shape, and then you go from simplified chords, you don't change it. Now you have more variation, and then finally you actually get the lead sheet, mostly the left hand of your piano. But anyway, so I think that the first part is like for presentation, I still think we are not there yet, because we have this like sequential view of music that sort of like sequentialize everything and hope transformer attention will capture all those things. It's doing something that's 2D inherently, but also a lot of things is actually you can see these chords is like translational invariant that you can sort of use the same chords and then you move it up, move it down, and then you move it horizontally. It's the same, right? And there's also like time and pitch. So I think about like a arpeggio, right? So you have like a arpeggio. You're basically doing horizontally and vertical cross product, right? Horizontally is dot, 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 and then vertically it's a chord. So you have this like 2-dimensional things happening in music, and I don't think that's actually currently being captured enough in our current symbolic music system. So I think there's still a lot of things. And also think about nowadays, we have so many like text to music models that just go directly to audio. And so we sort of assume everything will be done by the codec. But I think representation-wise, we still don't have a very efficient representation that can best represent music for machine learning. But maybe that's not a real question, right? Potentially, we humans also don't have an agreement on how we can best represent music. And so that's also why this deep learning thing is so much debate, right? A lot of time it's like black box, but sometimes black box model work better. And whenever you want to make it explainable, the performance drops. So I think there's still some discussion over there. Second challenge, I think, is multimodality. So one thing I noticed, so can AI learn to create music by listening to music rather than reading music? So this is again coming from my observation of symbolic music generation. Of course, nowadays we have a lot of like text to music generation, so it's better. But think about what happened in this symbolic music generation. It's basically just reading a bunch of scores, and then you hope the model will somehow just generate the music. But does that make any sense, right? Because like how humans learn to create music, learn music is through listening, but also sometimes, or a lot of times, practicing. And also, a lot of different cases, you can actually just look at different videos, and a lot of them, or in real life, we look at different possible occasions that we will expose to music playing, and that's all the signals that we are learning from. So, how can we actually move towards that kind of machine learning system that actually learn music in the way as human does, rather than just reading or just listening? I think there is more multimodality involved in this process, how humans learn music. But also, if you just think about from the application side, multimodal inputs for generative music AI, so nowadays text, image, and more video, but also think about emotion, think about EEG signals, think about the EMG signals that we've seen for the Yamaha collaboration. So a lot of them can actually become multimodal inputs for Gen AI, and I think we haven't explored enough, especially when you combine different pairs of inputs at the same time. Cool, so this is an example. Can I click it? So this is like, even before any of these music. Let me show it here. So this model is actually listen to the player, the pianist. So the audio actually passed through to generate the music. Cool, I will pause here. But what I want to say is that a lot of these real-time interaction, like all these different modalities, like real-timeness, interactionness, how can that actually be feedback to these deep learning models? And we are still exploring how to do that, and I think we haven't done enough. And so this is like 2015, even before all these deep learning models. So these are more like concatenating models that jump between different samples rather than actually creating new piece. But of course, like last week we had Doc Stu's in Anna Huang's lab is doing a lot of like this kind of research with current deep learning models. So I think we are still not there yet. But also Shimon, I talk a little bit about it. I won't play it for the sake of time, but this is like improvising robotic marimba player. It will look at you, kind of terrifying, but it will look at you and then nod their heads. That's like beat tracking algorithm, but think about what does it mean nowadays, especially when some of these would be AI creative agents. Oh, and marimba hands. So it's a clever idea, robots, but each of the hands will control each single stroke. Oh. Cool. So yeah, I mean, so yeah, questions? Cool. So for multimodality, I think that's the path towards some of these very creative and interaction kind of research that, or like a creative partners rather than something that's single button and then let it go kind of things. So a lot of humans interaction with music is actually through different modality rather than just listening or simply just reading the scores. A lot of them is actually sort of, we call it embodied nowadays, embodied AI, but the idea is that we have so many different multi-sensory inputs that's influencing the way how we are interacting with music. So that's the second challenge. The third challenge, I think likely most of you knows, how can AI music tools be integrated into an artist's creative workflow? So this is one of the things that I think that's very interesting because this wave journey is still, it's like 3 years before. But the core idea here is that they didn't actually train any new model. They basically just prompt GPT-4 and then ask them how do you write a script for a specific like a news? And so this is what the model come up with. So it's of course the model will generate some JSON, but tabulate view is just music, background music, at some point, the volume, and what do you want? And so once you have this caption, you send it to a text-to-music generation system. Now you have TTS, you have speech, welcome to Mars News, blah, blah, blah. And then the other guy, the other person, so that's like an interview kind of things. And then you have different sound effects, you have different music. And so, the whole thing, I think the key, I'm very interested in this kind of direction. I've also been working on some video editing, but I also think sound design and, film scoring can also go toward this path, is that this create an interactable intermediate outputs. So, think about what this means for, creators. This is basically means like a timeline in Premiere Pro, right? So these things are essentially equivalent, right? These are just like a tabulate format of this. So I've been always thinking about, how can we integrate Gen AI into the creative workflow? So multimodality interaction is one way, but there's also these kind of different kinds of interaction modes where professional creative workflow, how can you actually integrate AI that can generate these plans? And then potentially you can go search in your sampling audio library to grab different loops or different sound effects, or you just plug in a text-to-music generation system or whatever. But that allows you to actually interrupt or intervene the creation so that you are still in control of whatever you want to generate. So think about how does that apply to music. Haven't done much yet as a field, I think, but still think about, a lot of session file is definitely not like nowadays text-to-music generation system that's just like one tiny waveform. Not tiny, I mean one single string of waveform, but rather there's different kind of components at the same time, and there's some high-level planning, especially from film music or for music that's less experimental, more structured, so that you fit in the narrative. Then a lot of them has to be done in a structured way. So how can Gen AI be integrated into music creative workflow? And of course, more than just those. So this is one of the examples that's very cool. RAVE, real-time audio synthesis. So they created the synthesizer that's connected to XYZ and velocity of the controller, as you will see. And those are controlling the latent variables of an autoencoder. And so over the time, the user will learn different position in the space that will correspond to different sounds. And they actually make it embedded, so it can be run on Raspberry Pi, but also JSON Nano, as you will see. Let me fast forward. Cool, this is a motion sensor. So it's controlling these latent variable of the autoencoder. So audio in, latent variable, audio out. So, even though I think the original rave, it's like, if you machine learning wise, you think about it, it's like, well, isn't it just like a super tiny autoencoder? But once you make it tiny, once you make it real time, a lot of very interesting opportunity emerge. And so this is like a quote from Naoto Hokui. So throughout history, music and technology have often intertwined, with new technologies being misused by artists. So think about turntable and think about all different kinds of music that's being misused. So I think that's also when the technology mature, people now think about the different ways how you can actually unlock some of these new opportunities. And that's also why now Hokui also talk about, AI is more challenging to misuse because it lacks a physical entity and operates as a black box. So, this rave idea that you actually have an embodied system, now you make it more like an instrument so that you can interact with. Now you unlock so many different ways to misuse it. So I think this is a very, very important direction to move forward for Gen AI for music. And so, without deviation from the norm, progress is not possible. Cool. So, the challenge is about, how can AI music tools be integrated into an artist's creative workflow? And I think I deviate a bit from that, but that's sort of the idea. Personalization, this I will quickly go over this. So this is a project that if you're interested, you can take a look. So basically, Google Magenta worked with this team, and then they actually trained the model on their own labels, their own albums in the past 10 or 20 years. So this creates sort of like a personalized models for them. So a lot of things actually been happening in this space, but I think one of the biggest challenges is like, how can you enable easy or simple, friendly personalization? So, through fine-tuning our own models or through fine-tuning with live inputs on the stage. I think those are very exciting opportunities. So, Python scripting or friendly user interface, can we do better? So this is also one of the slides that I like to mention every time I give a talk. It's like overfitting versus distortion. Will overfitting be a new music expression? The distortion for AI music, right? Because you think about, distortion. Originally, people want to recreate acoustic sounds with electronic music, and later people embrace it with a new form of expression. Similarly, overfitting considered bad for machine learning. But you also see a lot of very interesting, while you overfit with your own albums, then that becomes the overfitting of your sounds. Can you tune overfitting so that make it even more yours, or make it less yours? How do you navigate with misuse these concepts that's considered bad in machine learning, but think about what would be the creative implication of those terms. So hopefully at some point we will think, maybe overfitting will be the new music expression. This I will skip. Cool. Last one is creativity. Can AI ever be creativity? How can AI augment human creativity? This will be very broad, but just to give you the sense, as Debussy said, works of art make rules, rules do not make works of art. So the curse of machine learning, I think a lot of you might have been thinking about this from time to time, especially working with LLMs. AI is only as good as the data it learns from. So the ability to extrapolate and think out of the box is not by default with machine learning. So can AI ever be creative? So if you are interested in this space, I think this is one of the nice paper to look at. So this is called Creative Adversarial Network. So what it does is that, if you know about generative adversarial network, is that you want to create something that's indistinguishable from the real ones. So it's sort of like a gaming. Like the generator want to generate something that cannot be considered as fake by the discriminator, and discriminator will just keep improving in tell real ones from fake one. But they add additional things, so they want to have this art style classification. So this discriminator, they actually train another classifier to classify the art of different artists. And so they train the model specifically to generate something that's not seen, cannot be classified into any artist. So these are some of the generated images. So you want to generate art still, but you don't want it to be classified as any single artist. So this is a very simple idea, but it does create some incentive for the model to create those, within genres or the boundaries of different styles. Of course, this is still far from, transformative creativity as we will see, but at least this is one of the ways that still within machine learning paradigm, but still we can have this kind of interesting or more out of the box terms or objective, so that encourage machine to explore the boundaries between styles. So let's get this. So 3 types of creativity. Currently, AI is still at this combinatory creativity. There is also exploratory creativity, but also transformative creativity. So combine concepts into new ones. So like the things that we see in creative adversarial net here, but still I think AI lacked the ability to do transformative creativity. But at the same time, does machine learning or deep learning, is that the path toward this? Who knows, right? Data-driven, maybe we are stuck on these, and we don't know yet whether we can enable this through the current, AI paradigm. Yeah, this is just like combinatory creativity, Michigan space Wolverine. So, likely never seen before, but, AI can do it. But, some of these transformative creativity, how do you enable that, right? Cool, so creativity is allowing yourself to make mistakes. Art is knowing which one to keep. I think that's a good quote to think about creativity versus just art creation, like creative adversarial net. Cool, quote by Scott Adams. Cool, so that's pretty much, hopefully not too overwhelming. So the 5 challenges, but I think those are actually can be turned into opportunities if you're interested in exploring. So representation, how can we best represent music for machine learning? I don't think we have an answer yet. Multimodality, I think not only can AI learn to create music, but I think that's multimodality is the way how we can actually make music interactable and unlock a lot of creative opportunities. Usability, personalization, and also creativity. Cool, so let's just conclude my talk, again, like music and technology co-evolves over the time, and now we are looking at AI, and there are so many opportunities, and how can we navigate and unlock new opportunities. Cool, so many slides, but last but not least, these are all my collaborators and all the companies that I've worked with, and also schools. Cool, thank you so much. Questions?
Amazing, a lot of ideas, a lot of things. Any questions?
Sure.
Like you did with the videos that you added that flow with the video transformer, make the audio better. Have you tried something similar with pictures, like
picture?
maybe artwork of a track or a band or an album?
Yeah, so the thing is like you couldn't get paired data, right? Because for video, film music, you can look at you know the connection, right? And people, you call it cliche, but I mean, it's like there is something linking the video and music. For image, I think there are also some, say, audio books or things like that you can actually create some paired data. But in general, image, I think for now, we don't have paired data. So of course, you can actually prompt LLMs. A lot of my students' project is about prompting LLM to just create some caption for the image they are seeing. LLMs can do something like that, but not data-driven. Yeah. Does that answer your question?
Yeah, I was thinking more about when a band releases an album, it has a certain artwork that might be correlated with the audio.
Oh yeah. There's actually a very cool project. Yeah, album, album cover to music generation. There's actually a famous paper on that, and also the other way around, music to album cover creation, but very loose connection in general. Yeah. Yep.
Yes. First of all, thank you very much for the talk. I would like to ask, for example, as an extension in this video concept, because now in this setting you took, for example, videos from movies.
Yep.
But movies and OSTs are trying to adapt to a specific genre and give it into a specific environment that the movie will be set up. But if the goal is, for example, to get a better representation of the human experience as a whole, meaning that, for example, you can add videos from dancing or spending time in a park, from, I don't know, different types of experiences and how the music aligns with it, in order to make a more general approach. Because from what I understood, this goes into the direction of optimizing, for example, movie concepts. But if you generalize this and have different types of experiences, do you think that
be able
to?
I think again, the question is about data. I mean, of course, you can prompt LLMs to do whatever, and you never know whether that's true. Sometimes it's good, cool, right? But I think think about I'm now in school of music, theater, and dance. I think theater and dance they are very interesting in exploring. And sometimes, for music, they don't know how to interact with music and how to get deeper integration. So there's actually a lot of I think also opera in the theater world, they are looking into can we actually have AI generate the visuals, music, sound effects at the same time where you are performing on stage, right? Because that's more dynamic than pre-program everything. So I definitely think there's a lot of opportunity, but again, the biggest question is it will not be data driven for now if we don't have any data. But still, without data, there's still a lot of things to explore. Yeah.
Something that got me thinking is this creative adversarial networks that you showed. I think it's a very nice idea. I was aware of that, but I didn't have it in my mind right now. And so one thing that relates to other things that you said also is that it's interesting. It's a way to kind of sample out of distribution, or let's say in the long tails. But I mean, a style. So in this way, you could eventually identify some specific instances of something that you haven't used for training. But actually, what you typically try to do when you define a style is much more than that, right? Like either with a human in the loop that helps you identify, okay, this is interesting. You'll try to find let's say some part of the manifold. Which is kind of interesting in a way, and it's more coherent, let's say. Have you ever seen something like that?
There's actually, I mean, it's well cited, and ICCC, they actually have a lot of follow-up work on that.
Right?
Yeah, so the idea is that, people always talk about the latest space things, right? Here is the rock, or here jazz, things like that. But I mean, creative adversarial network is sort of looking at these boundary cases. But at the same time, how do you create this taxonomy, right? So there's actually a lot of interactive sort of work looking at how do you identify these concepts at the same time. But I think those are not essentially, a lot of them are for explainable machine learning, but those are not essentially connected to this creative adversarial network kind of idea, that these are sort of the boundary of creativity. And I think that also connects to the idea of the curse of machine learning, is that LLMs or nowadays machine learning is what would be the most probable things, and people are well, that's not that important for creativity. But at the same time, this likelihood is actually sort of a confidence or level. So if you don't want the most probable one, and then you tone down a little bit, what are the possible ones that could be interesting. So I think if you fix in that machine learning mindset, then you always look at the century of these modes. But I think a lot of very interesting is when you are navigating those less likely parts. But the bigger question is, how do you create the taxonomy and how do you enable those exploration into those interesting areas of sounds? Yeah, mostly, latent space, people can just move around, but I don't think you have those like taxonomy embedded into the latent space. Yeah. I feel like there's still like a disconnection between explainable AI, but also for creative agency kind of thing. Yeah. Sure.
I want to ask about your kind of like view on pedagogy or like music pedagogical, especially practicing schools, like also you're based in this School of Music here in France. And I think I was lucky to have heard one of your collaborative research with you on Música.
Oh yeah.
On the AI Music Conference. And AI Music Studies Conference. And it's, so, let me just frame this. So I wonder if you see the space of, say, like, teaching, like, techniques, maybe with embodied AI, and also in your environment where...
Yeah, definitely. Yeah, so one thing interesting about Michigan is that we have a big athletic department, kinesiology, I forgot that term, but basically understanding all the muscles for athletes and the crazily huge budget. But I mean, think about musicians, and like every day, like music students are exposed to all these, injury. Right, and we haven't done much. So I think pedagogical, I mean, for higher education, I think it's very challenging for now. But think about K-12, but also, so for K-12, I mean, one of the things that has been explored a lot is difficulty estimation, right? When you started learning, you want to like have a curriculum. You don't want it to start from a very hard one. But I mean, sometimes people just like play those like nice piece that they want, and can you adapt it into simple piano version? So that's one thing that has been explored a lot. I also did something back in the past, but I sort of failed completely. So that's a very challenging task, but people have been exploring a lot. But for higher ed, I think there's also like injury prevention and hearing loss prevention. That's something I really wanted to explore, because nowadays I was looking at the other department that's like funded nicely, and all these like high-speed camera, all these muscle sensors, for athletes, and then musicians are like, have people done enough to look at the same techniques can be applied, right? But just that, what are the implications and what can we do for that? Yeah, I don't think I answered your question, but yeah, but I mean, pedagogically, yeah, I think there's tons of opportunities. I'm still exploring, so not yet done too much yet, yeah. Cool.
Okay.
Sorry, could you show us again the conclusion?
Conclusion slide?
We're so fast.
Which conclusion slide?
Sorry. The one with the questions, just to take a quick.
This one?
Yeah.
Oh, okay, cool. Yeah, this is a better way to stop. Yeah, sorry for fast forwarding stuff.
Okay, cool. Thank you again.
Yeah, thank you so much.